Great day, boys and girls. Let's take a look, mini mathematicians. Today we're going to be doing 5.1b lesson, function rules and function notations, the 5.1b extensions, and we're going to start 5.1c lesson, linear and nonlinear patterns, just 1 through 6. So let's get started on page 11. I'm looking at page 11. Are you looking at page 11? The title of today's lesson is 5.1b lesson, function rules and function notation. The first thing I'd like you to do is, with your two colors, one color assign to input, another color assign to output at the top of your page, and I'd like you to take 3 minutes to go through your entire lesson and underline in the input color anything that talks about the word input, and in your output color anything that talks about the word output. For example, input, I know X is the input value. Input, input, button is the input, G4 is an input. So let's continue doing that. Please pause the video for 3 minutes to have the students continue to highlight input and output. Oh, input. Continue for 3 minutes. Awesome. Hopefully your paper is all marked up similar to mine. Let's take a look. Another way to think about the X and Y variables is as input and output variables. Make sure to follow along with me as I read. To better understand how input and output values are related to a function, we'll investigate the following vending machine analogy. Remember, analogies are kind of like similes and metaphors. When you buy snacks from a vending machine, you push a button, input, and out comes your candy, output. Let's pretend that G4 corresponds to a Snickers bar. If you input G4, you would expect to get a Snickers bar as your output. Your output is determined by your button you push. If you enter G4 and sometimes the machine spits out a Snickers, but other times it spits out a Kit Kat bar, you would say the machine is not functioning. One input, G4, corresponds to two different outputs, Snickers and Kit Kats. This situation is represented by this mapping. Notice my input of G4 could go to a Snickers, but it could also go to a Kit Kat. Is this a function? No, it is not a function. So let's talk about a machine that's functioning properly. Taking a look at our mapping, if you had two outputs like a Snickers and a Kit Kat, we would need two inputs. So G4, I press G4, I get a Snickers. I press G6 and I get a Kit Kat. Awesome. Let's continue. When the vending machine is functioning properly, each input corresponds to exactly one output. And we talked about that a lot last class for something to be a function. The snack that comes out of the machine is dependent on the button you push. We call this variable the dependent variable. The button you push is the independent variable. Let's look at one more scenario with the vending machine. There are times that different inputs will lead to the same output. With some vending machines, companies may stock popular items in multiple locations in the machine. So we'll have a whole bunch of rows of hot Cheetos, because those are my favorite. This can be represented by the mapping to the right. Does this mapping represent a function? Explain why or why not. Talk in your groups. Do you think this is a mapping? Did you say yes? If you said yes, then you are correct. It is a function because each button or input corresponds to only one or a unique candy output. If I know the buttons that are pushed, I know the snack that's going to come out. So again, this mapping does represent a function because each button or input corresponds to only one or a unique candy, the output. If I know the button, I know the snack. I want to remind you that in a function, the set of input values is defined as the domain, and the set of output values is defined as the range. So I input my input value, or my domain. I put it into the function rule, and it comes out as the output value, or the range. We're also going to call this y. When specific input or x value is inserted into the function or rule, the output is a function of x. The output is represented as f of x, which means the function evaluated at x and is read f of x. That's called function notation. But I want you to remember that f of x is just a synonym for y. F of x is a synonym for y, and f of x is called function notation. Really important. So let's explore this a little more. Please turn the page. Looking at the next page, the table below, each input value x corresponds to an output value y. Imagine the input value going into a function machine and coming out a different number, the output value. Something is happening to the number in the function machine. Let's look at the directions. Each table of values given below represents a function. State the domain, remember that's the x values, the range, that's the y values, and the function rule. Then explain what the function rule represents. So domain values are all the x values. I'm going to write this in set notation, meaning I'm using curly brackets. I'm going to start with the least number, and I'm going to list them in increasing order without repeating any numbers. I'm going to do the same thing with the y, or my output, or my f of x. 15, 17, 21, 23, and 25. What function rule represents the table of values? Write your rule in function notation. That just means f of x equals. Well, to look at what my f of x equals, I'm going to go to the table and look at my rate of change. 5 to negative 3, I'm going to add 2. I'm going to check another one just in case my function's not linear. Negative 3 to 1, I'm also adding 2. 15 to 17, I'm adding 2, and 17 to 21, I'm adding 2. So my rate of change in y over change in x, is 2 over 2, or 1. So I think this is linear, has a constant rate of change. I know it's linear, so my slope is 1. Then I have to think about my y-intercept. I could use any point in here and use point slope, or I could look at the pattern. Negative 5 to 15, am I going to add or subtract? Oh, I'm going to add. What number do I add? I add 20. What number do I add to negative 3 to get to 17? 20. What number do I add to 1 to get to 21? 20. What number do I add to 3 to get to 23? 20. What number do I add to 5 to get to 25? You guessed it, 20. So my function is f of x equals x plus 20. Explain in words what the function rule represents. It represents 20 is added to each x value. You could say domain or input if you wanted to. 20 is added to each x value to result in, or to produce, let's say produce, to produce the corresponding y value. We input x and we output y. Excellent. I would like you to try number 2 with your groups. Go ahead. I'm going to give you 2 minutes. Please pause the video for 2 minutes. If your whole group finishes, you may move on. Okay, let's take a look at number 2. Let's see how you and your group did. Looking at number 2, what's the set that represents the domain? The set of domain values are -9, 0, 3, 12, and 30. The range values are -3, 0, 1, 4, and 10. My function in rule and function notation is f of x equals 1/3 of x. You can always check one of your points in your rule to double check. So I want to take a look at my check. I use the point f of 0. F of 0 means when x is 0. When x is 0, I substitute it into my equation, I get 0. Is f of 0 0 in your table? Why, yes it is, so I know I have the right rule. Explain in words what your function rule represents. 1/3 of each x value produces the corresponding output, or the y value. And again, you can use your table to find your slope, or you can just look at the pattern. Wonderful. Let's move on. Next set of directions say use the words input and output to describe the function rule for each of the following relations. Write the function rule as an equation using function notation. If the relation is not a function, explain why. So looking at number 3, I'm going to investigate my table. The first thing I'm going to look at is to see if this is linear. So to go from 12 to -9, I need to subtract 21. And to go from 7 to -14, I need to subtract 21. Then let's look at another one to make sure this is linear. 4 to -8, I subtract 12. And -1 to 13, I subtract 12. So I know that my rate of change is change in y over change in x, +1. So let's take a look. So function rule, f of x, I'm going to input x. My slope is 1. How do I go from 12 to 7? Oh, I subtract 5. How do I go from -9 to -14? Subtract 5. How do I go from 4 to -1? Subtract 5. We can continue that pattern down our table. So we know our function rule is f of x equals x minus 5. So let's see the function description using words, and we have to use the words input and output. Each input minus 5 equals the corresponding output. Excellent. I would like you and your group to continue on and finish number 4, 5, and 6. Go ahead and finish 4, 5, and 6. I'm going to give you about 3 minutes per problem, so that's 9 minutes. Please set 9 minutes on the clock and continue for the next 9 minutes. Good luck. Pause the video now and put 9 minutes on the timer. Okay, hopefully that was enough time to pause the video. Taking a look first at number 4. Number 4, when I investigated my table, I noticed that my rate of change was 3. And then I said, well, every time after I multiply my input by 3, if I add 1, I get to my corresponding output. So taking a look at that function description, 1 more than 3 times the input equals the output. F of x equals 3x plus 1. And I decided to check when x is equal to 1. So f of 1 equals 3 times 1 plus 1. F of 1 equals 3 plus 1. Is f of 1 4? When x is 1, y is 4. So yes, I have the correct rule that matches my table. Wonderful. Let's move on to page 13. Taking a look at page 13 to look at